Hi guys, this is Prashut again. Today we will describe some more theories of complex numbers. In my earlier video, we have described what is a complex number and what are the general properties of complex number. In this, we will describe more and we will go into more detail like what is the Argand diagram, what is geometric representation of complex number, how to represent complex number in a polar form. These types of things will come in your joint entrance as well as IIT examination. So I have tried to make this tutorial short also because if we take more time into the theory, then the problem and solutions time will be lesser. So just I have cut it short and I have put the major concepts over here so that you people can complete this exercise in a very smaller time and then you can go for the problems and solution. Proceed. First one is the modulus and conjugate of a complex number. If you are getting any problem in your exercise, then you will first associate it with the terms what is a modulus and what is a conjugate of a complex number, because with the modulus and conjugate they will give you the modulus and conjugate, they will write you to prove some formula, or they will ask you to find out the complex number and so on. So let's see what is a modulus and conjugate of a complex number. We can take the complex number with the simple example, that is a plus ib, and z is the notation, so z equal to a plus ib be the complex number. Modulus of z, which is denoted by z and two pipe sign in the left hand side and in the right hand side, that is a common notation of modulus, is defined to be the non-negative real number. So and its value is root over of a square plus b square if a plus ib be the complex number. So I am just root over the all the real parts of the complex number, summation of the real parts of the complex number. So this is the modulus. Modulus means the magnitude, basically magnitude. What is the magnitude of a complex number? So I can write mod z equal to root over of a square plus b square. The conjugate of z, which is denoted by z inverse, I will just put a bar sign on top of z, so that is called conjugate. So conjugate of z is the complex number. Like if I change the sign of the I, then it becomes the conjugate. Here in the example, z equal to a plus ib, so conjugate of z equal to a minus ib. So that is a common notation which is used everywhere. So I have got the formula for modulus. Modulus is root over of a square plus b square, and conjugate is conjugate of a plus ib equal to a minus ib. Let's take some example that will be clear. So for the complex number 3 plus I and 2 minus 5i, we will find out both modulus and conjugate. Okay, let's proceed. So for 3 plus I, the modulus will be mod z equal to root over a square plus b square, a equal to 3, so root over of 3 square, plus b equal to 1, so plus 1 square, equal to root over of 3 square equal to 9, 1 square equal to 1, so 9 plus 1 equal to 10, so root over of 10. Next let's go to the and conjugate of 3 plus I equal to just 3 minus I. That's it. Similarly for the second problem, 2 minus 5i, the modulus will be mod z equal to root over of a square plus b square, a equal to 2 square, plus b equal to minus 5, so minus 5 square, so 2 square equal to 4, minus 5 square equal to 25, 25 plus 4 equal to 29, so it is root over 29. Now the conjugate, you will be able to tell this verbally, that is 2 plus 5i. Okay. So this fact, modulus and conjugate are used in simplifying expression where the denominator of a quotient is complex. Simplify the expression. Let's take another example. This is 4 plus 7i divided by 2 plus 5i. In these types of problem, I have come across this problem in my earlier video also. So at that time, I asked to multiply with the minus sign of the denominator both in the numerator and denominator, but I did not tell you why. Now here is the reason. Here if I multiply both numerator and denominator with 2 minus 5i, that is the conjugate of 2 plus 5i, then the solution will come to a simple expression that it is, we can put this in the form of a plus ib, which is the simplest form of a complex number. So let's see how. So 4 plus 7i divided by 2 plus 5i into, I am multiplying both the numerator and denominator with the complex conjugate of 2 plus 5i, that is 2 minus 5i. So just simply multiplying it, 4 into 2, 4 minus of 4 into 5 into I plus 7i 2 minus 3 into 5i into 2 divided by 4 minus 20. In the denominator it is a plus ib into a minus ib, this from, so a square minus b square, so 4 minus 25i square. So denominator becomes 4 plus 25, that is 29, and the numerator, if I sum these things, 8 plus 35 equal to 43, and minus of 20i plus 14i equal to 6 minus 6i. So it becomes 43 by 29 minus 6i by 29. So this is a very simplest form of a complex number, that is, it is coming as a plus ib. So this is the reason to multiply with complex conjugate. So we have discussed about modulus, we have discussed about conjugate of a complex number, and we have solved a few very simple examples. Let's go to a new thing which is called Argand diagram. What is Argand diagram and why it is needed? Argand diagram is the pictorial representation or the graphical representation of a complex number we used to do through a Argand diagram. Any complex number z equal to a plus ib can be represented by an ordered pair ab and hence plotted on xy axis, with the real part measured along the x-axis and the imaginary part we used to put in the y-axis. So the graphical representation of the complex number field is called Argand diagram, and this particular representation has been invented by one Swiss mathematician. His name is Jean Argand. So with his name, this diagram is called Argand diagram. So let's see what is this. If I see this particular plane, if you see the graph, in the x-axis plus x-axis we have put 1 2 3 4 5. In the, there is the imaginary axis which is the y-axis, basically there we have put 1 and 2. With the, I know that the first quadrant is plus plus, second quadrant is plus minus, third quadrant is minus minus, and the fourth quadrant is third quadrant is minus minus and fourth quadrant is plus minus. So in this way we know. So I will put some of the expressions over here, so then you will be able to, then the concept will be clear to you. Let's take some example how to represent this in a Argand diagram. First example is z equal to 3 plus 2i. We know 3 is positive and 2i is also positive. So if I take 3 in the x-axis and 2i in the imaginary axis, so my expressions is becoming z equal to 3 plus I 2i, and I have put in the first quadrant of this graph. So z equal to 3 plus I 2i. I think now you can see the pointer, mouse pointer here. I have put, this is 3 and this is 2. So 3 and 2 point will be located over here, and it is becoming z equal to 3 plus 2i. If I take the second example, z equal to 4 minus 5i. So you just tell me where I will put 4. 4 means it is real, so 4 is over here in the x-axis, and minus 5 means minus of imaginary axis. Imaginary axis is y, so minus 5 means minus 1, minus 2, minus 3, minus 4 and minus 5. So it is becoming over here. So this is z equal to 4 minus 5y. Third example is z equal to minus 2 minus I. Okay, so minus 2 means minus real axis, so it is coming over here, minus 1 and minus 2. So this is here, and minus I means minus 1I. So minus imaginary axis is over here, so it is becoming z equal to minus 2 minus I. So this is the representation of complex number in the Argand diagram. I hope this is clear now. Let's move to some more geometrical representation, that is called polar. It is called polar coordinates. Okay. Consider the complex number z equal to 3 plus 4i as represented on an Argand diagram. So in the Argand diagram, if I see, as I discussed earlier, 3 plus 4i means 3 is in the real axis, so 3 over here, and 4i, so it is also plus, so plus of imaginary axis, that is here, so the number becomes over here, so it is 3 plus 4i. And using Pythagoras theorem, if I put the length OA equal to the hypotenuse of a rectangular triangle with having base as 3 and height as 4, so it is root over of 3 square plus 4 square equal to 5. So mod z we can write equal to r equal to 5. So mod z is read as the modulus or the absolute value of z. The modulus we have already discussed. So the angle OA makes with the positive real axis theta. This is the OA. OA is the complex number, and this complex number has made with the positive real number theta, that is this particular angle. This called will be decided by theta equal to tan inverse 4 by 3. Why 4 by 3? Because tan equal to perpendicular by base, so that is 4 by 3. So for tan inverse 4 by 3 equal to 53.13, you can find it out in the through calculator, or this is written as argument of z, that is 53.13 degrees. So this is called the argument. Argument means a complex number, whatever angle it is posing with the real axis, so that's called the argument of a complex number. And modulus is the value of the hypotenuse, like OA. Here the OA value is basically the absolute value of the complex number. Hope this is okay. Let's proceed to the how to represent this. The parameters z and argument z are in fact the equivalent of polar coordinates r and theta, as shown opposite. Opposite means in the left hand side the figure. This is a simple, there is a simple connection between the polar coordinates and the Cartesian or rectangular form, that is AB. So A equal to r cos theta and B equal to r sin theta. If I consider this particular figure, you can see the coordinate is A and B, x coordinate over here and y coordinate over here, the complex number for the A and B. So r is, let's say this particular complex number is r, so it will give you, and this angle is theta, so A equal to r cos theta and B equal to r sin theta. So that is the portion they are mentioned. So therefore z equal to A plus IB, we can put A, I know A equal to r cos theta, and I into B means r sin theta, so r of cos theta plus I sin theta, where z equal to r and argument of z equal to theta. So it is the usual form of polar coordinates, like z equal to r of cos theta plus I sin theta. Now we have to find out in different problems the value of theta and value of r, so that we can represent a complex number into the polar coordinate. Okay, so this, let's take some more example. In the diagram below, like the point A could be labeled as, let's say this is a point A. This point is on top of x axis something around 3.5, and in the y-axis it is somewhere around 2. So I can put it over here. So the point A could be labeled 2 root 3 comma 2. So 2 root 3 comma 2 or 2 root 3, so if the point 2 root 3 comma 2 as per the diagram, so it means 2 root 3 plus 2y. The angle that OA makes with the positive x-axis is given by theta. Theta equal to tan inverse of 2 by 2 root 3, because tan inverse of perpendicular by base. So 2 by 2 root 3 equal to tan inverse of 1 by root 3. 1 by root 3 means tan 5 pi by 6. So theta equal to pi by 6, or theta equal to 2 plus pi by 6, or 4 pi by plus pi by 6. So there is an infinite number of possible angles, because this is normal situations like in trigonometry. Whenever you will go to trigonometry, you will be able to understand. The one you should normally use is the interval. We generally try to use in the whenever theta equal to less than pi and greater than minus pi. So this is called the principal argument. So using polar coordinates, the point A could be labeled with its polar coordinates r and theta. I know I have discussed it earlier. So if I considered with r and theta, so r means 4 and theta means pi by 6. So 2 root 3 plus 2y I can put as a polar coordinate as r of cos theta plus I sin theta. So r means 4. So 4 of cos of pi by 6, because theta equal to pi by 6 I have defined, and I of sin by pi by 6. So this is the fundamental theorem of polar coordinates, how to put a particular complex number into the polar coordinates. So that's all from the theory perspective. Let's go to problems and then we will be able to understand this concept. Thank you. Thanks for watching this video. I think the complex number, this polar coordinates and modulus argument, these things will help you to prepare, and after that whenever you will go through the problems and solutions, at that time the concept will be more clear. Thanks for watching my video. If you like my video, please like on the like button and subscribe me so that it can be reached to wider audience. Thank you and have a good day.